Let us do another question set. Let us get started with the first question. So you have this expression, what is its value? Well, do you know the law of indices of a raised to m divided by a raised to n? Well, it is equal to a raised to power m minus n, and vice versa. So we have a similar situation here. I can write this as 1 divided by 1 plus I have a raised to power n minus n. So something similar to this, a raised to power m minus n. So it is a raised to power n divided by a raised to power m. Similarly, on the right hand side of the plus, we have 1 by 1 plus a raised to power m minus n can be written as a raised to power m by a raised to power n. So this is equivalent to, I have 1 by, this can be written as a raised to power m plus a raised to power n divided by a raised to power m, plus 1 by, again, a raised to power n plus a raised to power m divided by a raised to power n. So this is equivalent to, this a raised to power m goes up, here also a raised to power n goes up. So a raised to power m upon a raised to power m plus a raised to power n, plus again a raised to power n upon a raised to power n plus a raised to power m. So the denominators are same, so this can be written as, in the denominator I have a raised to power m plus a raised to power n, and on the numerator I have a raised to power m plus a raised to power n. So the denominators and the numerator are same, so both get cancelled out. So what remains is 1. So the answer is option C. Whoa, quite a big question. Well, it's a challenge. What is the answer? So I can write this expression as, let us write it, the first part 1 upon, I have 1 plus x raised to b minus a can be written as x raised to b divided by x raised to a, plus I have x raised to power c minus a, so I can write it as x raised to power c by x raised to power a. Let's move to the second part. I have 1 upon 1 plus x raised to power a minus b. I can write it as x raised to power a divided by x raised to power b, plus x raised to power c minus b. I can write it as x raised to power c divided by x raised to power b. And moving on to the third part, I can write it as 1 by 1 plus I have x raised to power b minus c, so it becomes x raised to power b upon x raised to power c, plus x raised to power a minus c will be x raised to power a upon x raised to power c. This is equal to, again, the first part I have 1 upon, taking the LCM of the denominator, which will be x raised to power a, so x raised to power a, this is x raised to power a plus x raised to power b plus x raised to power c, plus the second part now 1 upon, I have in the denominator x raised to power b, then x raised to power b plus x raised to power a plus x raised to power c, plus the third part now, again 1 upon, in the denominator of the denominator I have x raised to power c, and in the numerator of the denominator I have x raised to power c plus x raised to power b plus x raised to a. So these denominators go up. This is equivalent to x raised to power a upon the denominator is x raised to power a plus x raised to power b plus x raised to c, plus the second term is x raised to power b upon, we can rearrange the denominator, it is x raised to power a plus x raised to power b plus x raised to power c, plus the third term I have x raised to power c in the numerator, in the denominator I have x raised to power a plus x raised to power b plus x to the power c. So now we can take the denominator common because the denominators are same. So I can write this as, in the denominator I have x raised to power a plus x raised to b plus x raised to c, and in the numerator I have x raised to a plus x raised to b plus x raised to c, and both the numerators and the denominators are same, so it is equal to 1. So option B is the right answer. Let us now move on to the third question. What is the value of x if you have been given these two expressions? Okay, so let us analyze 27 first. 27 is the cube of 3. So I can write 3 raised to x minus y is equals to 3 cube. And now let us analyze 243. So let's find out how we can represent 243 as a product of its prime factor. So 243 is there. Let's divide it by 3. So I get 81. Now 3 times 27 is 81. 3 times 9 is 27. And 3 times 3 is 9. So 1, 2, 3, 4 and 5. So 3 raised to 5 is 243. So I can write 3 raised to x plus y is equals to 3 raised to power 5. So from this I can say that x minus y is 3 and x plus y is 5. So I have x minus y is equals to 3 and x plus y is equals to 5. Now we have two equations here, 1 and 2. Solve it simultaneously. So add equation 1 with equation 2. So we are adding it. So x plus x is 2x, minus y plus y gets cancelled out, 3 plus 5 is 8. So x is 4. Therefore we can say that option C is the correct answer. Now what is the answer of this final question, which is quite colorful? Now we have been given a raised to x is equal to b raised to y is equal to c to the power of z. So we can write a to the power of x is equals to b to the power of y is equals to c to the power of z is equal to k. Now a raised to power x is equal to k. So I can say that a is equals to k to the power of 1 by x. That means x is root of k. And b is equals to k to the power of 1 by y, and c is equals to k to the power of 1 by z. Now we have been given this value, b square is equals to ac. Put the values of a, b and c in this equation and hopefully you will get a relation between x, y and z, and from that you can find out the value of y. So b square is equal to ac. So b's value is k raised to power 1 by y. So k to the power 1 by y square is equals to a is k to the power 1 by x. So k to the power 1 by x times k to the power 1 by z, which is c's value. So on the left hand side I have k to the power 2 by y is equal to, this is a multiplication, so I can write k to the power 1 by x plus 1 by z. Now these values are same, so I can equate the powers. So I can write 2 by y is equals to 1 by x plus 1 by z, and that can be simplified to, I can write 2 by y is equals to z plus x upon xz, and that is xz goes to the left, so 2xz upon this z plus x goes down to the left hand side of equals to, so x plus z is equal to y. So we have y's value as 2xz upon x plus z, and that is option D.